Today we're going to talk about three steps towards data-driven success via smart manufacturing. We'll try to explain what smart manufacturing is and how we can get towards smart manufacturing in simple steps that are not cumbersome for the plant or the manufacturer. So actually today we use a lot of digital tools in our daily lives. Here are some examples that we have. For example, we use Uber Eats to order food from any restaurant that we like. We use chat applications like WhatsApp or other applications where we can actually chat with our friends, with our family in groups. And we use applications like weather forecasting, and then we get alerts from each of from any application, like if there's a rain or if there is any thunderstorms, we get an alert on those. So actually, when we order food, we do not have to go to the restaurant. We don't even have to call the restaurant and explain to them what we want. We just actually use the app, and the food that we like just comes to our place. And actually, you can even track the driver. You can see his estimated time of arrival, and that actually now that estimated time of arrival gets updated in real time. Or if we're going out for a weekend, we actually first look at the weather, we look at the forecast, and depending on what the forecast is, we dress appropriately, and then we take the tools that's necessary. If it's sunny, we dress like that. If there is thunderstorms, if there is rain, we actually dress or get ready for that. And then if there is anything that's happening that's wrong, or that there's an alert, actually we get it in our phones. So if you think about all these different tools that we use, it's very comfortable for us. It's very convenient, and it actually gives a peace of mind to us. And we have very little surprises. We can almost predict the future, and we can actually be ready for what's to come. So there are very little surprises, and actually this whole system, this whole ecosystem of digital tools improve our lives. So in order to achieve all this stuff, so how does these tools help us in real life? Actually, they provide us real-time data. So in the Uber case, for example, we know the location of the driver, which actually means we know the estimated time of arrival. So it's based on real-time data. It helps us communicate with each other. And since we know the estimated time of arrival, actually we can plan ahead and when we will start eating, and then the activities following that. And all these tools helps us act and improve our lives, and also it helps us mitigate risks that might be coming on our way. For example, if there's a thunderstorm, or if there's a hurricane, or if there is a tornado coming up, we actually get alerted immediately. So we use all these digital tools, and it actually is very comfortable for us. How about we use similar tools in our manufacturing lives, right? Why? I mean, it would be really, having access to each of these tools in daily life is very trivial, or is very natural for us. But the same tools actually are available in our manufacturing life, right? So we can have tools where we can actually get real-time data. It'll help us communicate with our counterparts, with the shop floor, with the white-collar workers. This real-time data will allow us to plan ahead and to act as soon as we see a problem. And then actually we can improve our processes with these digital tools, right? And then we can mitigate the risks that are coming on our way. For example, I just selected a few of the tools that we have, which is actually very similar to the tools that we have that we use in real life. For example, this production quantity forecast tool we have is showing in real time how many products the machine has completed so far. What was our current target? What is the shift target in terms of amount of products that we want to produce, and whether we are ahead of the plan or behind the plan. So actually, this tool is very similar to the estimated time of arrival for an Uber driver, right? And since we know when this production or work order will finish, we can actually plan ahead, and we plan ahead for the next work order. We could be getting ready, and we know exactly when our order will be finished, so that we can be ready to do the succeeding like packaging, etc. applications to the product, to the work order. We actually know our performance values in real time, right? So for example, here you can see our OE values, availability, performance, quality. So we know this in real time. We know how efficiently we use the shift. So we know how much time the machine ran, how much time there was stoppage. And also we have a tool that's very similar to the alerts in a weather application. We actually know as soon as there's a quality problem, or as soon as there's a stoppage target that was exceeded within a machine. So we could actually get, and these alerts can be very different depending on who you are. And you can get these alerts immediately, right? And also in terms of improvement, or in terms of analyzing data, the system digital tools gives us a lot of flexibility. For example, this graph here is showing me what are my biggest contributors to quality problems, right? So here it's actually showing me scratch. It's hard to see, but for example, the biggest problem that I'm having is scratch, and that's actually constituting about 45% of my problems. And the next quality problem is missing piece, wrong color, assembly error. So actually these tools also gives us helps us in terms of analyzing what's wrong, analyzing our losses, and actually improve upon those losses and see the progress as we go, right? So this is, again, having all these tools, just like in real life, having these tools in manufacturing actually gives us peace of mind, right? If you think about your life in manufacturing in a shop floor, I'm sure you can think of a time where you come in the morning to the shop floor, and there's a big problem with one of the machines, right? There's a crisis, and the machine is down, order is not fulfilled, and the customer is waiting, and people are yelling at each other. So in order to not have these type of crisis situations, actually you need a system like this, just like you have in real life, so that you have a peace of mind, you're feeling comfortable, and you have very little surprises going on in your plant, right? In order to do that, again, we need just like in the real world examples, or just like in daily life examples, we need access to real-time data. We need tools that helps us communicate with each other within the shop floor, between the departments. We need plans, and we need to see the status of our plans, when they're gonna whether our actual situation in the shop floor is according to our plan or not. And then we need to get alerts in real time, that where our targets are not reached, so that we can act and improve our processes. This way, actually, we can also mitigate risks, just like we do in our daily life. So this is the I'm going to explain in the remaining slides how we can get to this point, and what are the steps to get to this point where you're really comfortable with your operations in your plant. You have an operations management system where you have very little surprises happening, and then you keep improving your processes within your manufacturing domain. So I'm just going to give a little bit of a background on ProManage today. So we are actually we've been working on these systems actually since 1998. So we've been working on digital manufacturing solutions for the last 24 years. Chicago is our headquarters, and the only product that we work on is the only domain that we work on is IoT-based digital manufacturing management systems. We have an on-premise and cloud solution. We also have IIoT devices for data collection, where the machines are not Industry 4.0 ready, or they're not smart, so we have to retrofit them with our IIoT devices for data collection. We also do implementations in AI and machine learning, where, for example, we can do for companies that are really mature in digitalization, we can do predictive maintenance, predictive quality, but we can also use computer vision to count products, to estimate or to find defects within a product by looking at the camera, by using the camera and high resolution cameras and high frame rate cameras. We can also do assembly line operation verification. So in the assembly lines, the operators do certain tasks, and we can actually use computer vision again to verify the task the operator has just completed, and we won't let the product go to the next station unless the operator's operation is valid. So we work in mainly discrete and batch manufacturing, so automotive, metal processing, home appliances, plastics, food, FMCG, packaging. Those are the industries we're very heavily invested in. We have about 130 plus engineers working on this product, and we mainly have 4 different types of engineers: electronics, mechatronics, computer, and industrial engineers. Electronics engineers are the ones that are designing our IIoT devices. Mechatronics engineers are the ones on the factory floor where they help us get data from the machines, connect our IoT devices to the machines. Computer engineers are developing our software and improving the software continuously. Industrial engineers are the ones facing the customer, facing the manufacturers. They do implement the solution with the customer. They train the customer on the solution, but also they make sure that the processes in the manufacturer is improving all the time, and they they work with the customer to guide them to improve their production processes and make sure their losses are getting reduced over time. So we are pretty much all over the world. We have our headquarters is in US. We have presence in South America, a very heavy presence in Europe, Far East Asia, Japan, China, Pakistan, India, and also we have presence in Africa. Right now, we're tracking more than 30,000 machines at 300 plus customers in 5 continents. And we, as I said, we cover pretty much all discrete manufacturing. So anything related to any machine in plastic injection, CNC machines, stamping machines, any machine that's in discrete manufacturing, we can easily work with. So these are some of our customers. You will see some familiar names here, like 3M, Haribo Gummy Bear Company, Siemens, Schneider, Nitto, Lincoln Electric. A lot of companies in automotive suppliers like Maxion Wheels, ZF, Denso. Also some home appliances companies like Bosch Siemens Home Appliances, Beko, packaging companies, pharmaceutical companies. Ford is in some of their factories are using our solution to manage their production operations. So some typical benefits, and I'll get into this a little bit more in the coming slides, but Bosch Siemens Home Appliances using our system since 2002. They have seen about 18% improvement in their OEE, 20% reduction in breakdowns, and 30% reduction in setup times. Maxion is a wheel company. It's a worldwide wheel company, one of the biggest wheel producers in the world for automotive. They've seen 20% improvement in overall equipment effectiveness, 75% reduction in breakdowns, and 80% reduction in setup times. So eventual value proposition, the way we work towards is when we start with a company, or if you take an average machine, you take an average company, take a standard company, any company, and look at their machine utilization. In a given time frame, it could be days, weeks, only 40% of that time frame actually is being used for selling products that they're using only 40% of the time to produce a product that they can actually sell. All the rest is actually wasted with setup times, waiting, machine failures, quality losses. So there are different types of losses each machine does endure. And actually, if you don't use a system like this, you're typically 40% of that machine utilization or actually lower. Our goal is to get you from 40% to 85%. And I'm going to explain actually how we do this. And the first step to do this is actually measuring and having a knowledge of these times in real time, right? So if you don't measure it, there's no way you can actually improve it. So our first target, our first step towards manufacturing starts with actually collecting real-time data, right? So for example, it starts with our lowest package, which we call monitoring package. In this package, we actually do real-time getting data in real time from the machines, right? We get production quantities, run and stoppage intervals, whether the machine is running or stopping. Cycle times are recorded by machine, date and time. And then we can actually start analyzing the data and start carrying your business on your mobile. So you can actually access this data anywhere in the world. So this is the first step towards smart manufacturing. The second step, once you are actually once you are comfortable with data collection, once you verify your data collection, we actually get to the next step, and we have a checklist at the end of each step. We have a checklist that kind of verifies that you are on the right track, and that actually also prepares you for the next step. The second step we have is the digital package, um, where actually we now invite technicians and operators to the digitalization. In the first package, there is no involvement from the factory floor. There is no human interaction with the system. It's all on the background data collection. But with the digital package, now actually we have the technicians and operators are part of digitalization. So we do this step by step, right? We get the technicians and operators into digitalization. When technicians and operators are in digitalization, actually what we can do is the operators actually can see their KPIs, see their performance in real time. They can also enter information to the system, right? They can with this digital improvement package, actually we now have stoppage data, the duration of the stoppages, the reasons for stoppage, and scrap amounts and reasons. With the digital package, actually, you can now recognize the bottlenecks. You can understand what are the root causes of your losses and start eliminating them. Once actually the technicians and operators are part of digitalization, now actually you're ready to go to the next step, which is our advanced operations management functionality. With the operations management functionality, you now have actually product and work order data that's coming into the system as well. And you can actually do workstation-based real-time planning. You can plan each of your machines. And since you can get real-time data from the machines, you can actually see your progress towards your planning. Our connected package, or all of our packages are no-code configuration tools, which means actually there's no coding that you need to do. If your configuration changes, or if let's say you start with plastic injection but you added CNC machines to your system, you can actually just configure those new machines with our configuration tool without the need to recode, or without the need to customize it for you. With the connected package, where we're doing advanced management functionality, we can actually integrate with your ERP as well. If you have an ERP system where you have product and work order definition, or you can even do your planning in the ERP, with that actually we can get the product data or product information from your ERP. We can get real-time work order data from the ERP, and we can actually do, since our system is collecting real-time data and doing the organization on your manufacturing plant, we can actually send data back to the ERP, like the production counts, stoppage times, stoppage reasons, scrap amounts, and scrap reasons. So this would be a fully connected, fully digital advanced manufacturing operations functionality. And our recommendation for the companies is especially for SMEs is not to do a full-on digital manufacturing solution, but do it in steps, as I explained here. So the first step would be, again, just to repeat, the first step would be to start getting data collection, because data is essential to be able to make decisions within your factory floor. Without data, without real-time data, it's really hard to see what's going on in real time. It's really hard to be aware of the problems as they occur, and to fix those problems immediately, right? So first step would be data collection. The second step would be getting your people involved, getting your shop floor personnel involved, so that actually you get more data, and this data that you get with the involvement from your operations and technicians actually will help you recognize the bottlenecks in your production operation, the root causes of your problems and losses, and actually you'll start eliminating those losses. And once you're comfortable with this stage, once you're shop floor people are comfortable with digitalization, you can actually go to the full advanced operations management functionality. That'll actually be the third step. And with this step, actually, you are now a company that's a smart manufacturer, and you should see a lot of improvements that I'm going to explain in the next slides. Let's see if there are questions. So we have a question: how do you improve wait times in a machine? Let's go back to the previous slide. In order just to explain this slide again, any company, any manufacturing company within US, typically their machine utilization would be around 40%, and the rest of the time, the 60% is losses, setup losses, waiting losses, machine failures, and quality losses. And assume you have a smart manufacturing system where you're actually measuring these values in real time. So you're measuring how much your machine utilization is, how much your setup time is, how much you're waiting, what are the sources for waiting, how much your machine is failing, what are the quality losses. So let's focus on waiting as the question comes from about waiting. So waiting can be in different forms. For example, waiting can be the machine could be waiting for raw material, or the machine could be waiting for a tool, or it could be waiting for a semi-product, right? So let's say if it's waiting for raw material, let's focus on raw material. And let's say you have a fully functional smart manufacturing system, which means actually you know exactly your wait times. You know the cycle times for any product that you have, you know the average cycle times, and you know in real time which product you're producing. And you have a work order. Let's say you have a work order, you have a product that you're waiting, and since you know the cycle times, and since you know the raw material required for each of the cycle type, actually you can estimate exactly when each machine needs to be replenished with raw material. And let's say you have 50 machines or 20 machines, you can actually see when you can estimate exactly when a machine needs raw material. And you can put a large N on screen or large TV screen in front of the guy who is responsible for raw materials, and he'll know exactly which machine to attend to in order to replenish the raw material. With these kind of techniques and strategies, actually you can eliminate waiting totally. Waiting should not really be happening in a manufacturing in a smart manufacturing plant. You can do a lot of activities like this for setups, machine failures, quality losses, and our industrial engineers actually work with the manufacturer to make sure, or to find ways, or to suggest them ways to reduce these wait times, so that actually you can go from 40% to 85%. And if you think about it, actually going from 40% to 85% is actually more than doubling your machine count without really buying new machines, right? This is equal to producing double the amount of product that you're producing without really making any new machine investment. So we talked about these three steps. You start with data collection with the monitoring module. You include with the monitoring module, actually you don't have any involvement from your team. And typically what we see is actually manufacturers need to get ready in terms of infrastructure, in terms of people, in terms of culture to get to the final stage of smart manufacturing. So each of these stages actually prepare them for the ongoing journey. So the first step is again real-time machine monitoring. This is on the background data collection where you can see your production quantities, run and stoppage intervals. The second step is now your actually people start getting involved in the manufacturing, in the digital manufacturing process. So your technicians and operators are part of your digitalization. And then actually you can get more information, and you can actually, with the digital package, you start recognizing your bottlenecks, root causes for losses, and then actually you can start eliminating, you can start improving your processes. And with the third package, which is the advanced operations management functionality, you actually have a full view of which product is being worked on, work orders you can see in real time, and actually you can do real-time planning, and you can see the estimated times for in real time when the work orders will be finished. This you can also do, and this is an optional. If you have an ERP system, you can actually integrate with the ERP system. So this would be a full advanced operations management functionality implemented in your plant. Actually, once you are at the smart manufacturer stage, you're at the third stage. The smart manufacturing journey does not end. Actually, it's an ongoing journey where you can actually digitize more and more of your processes. So here we have additional modules that you can add on top of the full manufacturing functionality. And I'm going to talk about some of those as well. So, for example, we have maintenance operations management. So in addition to your production operations management, you can actually do maintenance operations management, where you can actually, since we know the amount of product that's produced in real time, we can actually do plant and preventive maintenance operations and repair operations, and you can actually manage and schedule these within the system. And also you can manage your spare part inventory to minimize machine failures. So this would be a maintenance operations management system, not just based on time, but also based on the real production amounts within the system. We have quality test operations management. This is actually doing quality test plans based on the product type and having the quality test plans presented to the operator or the quality personnel, kind of forcing them to do those tests before they can move on to their next production. We can actually integrate with the machine, with the quality test equipment. Like, for example, we can do a Bluetooth communication with a measurement device. The system also records all the quality test results, and actually you can do statistical process control analysis on the quality metrics. So this is predictive quality operations management. So you're again getting the quality tests in real time. You're doing statistical process control on those to make sure your quality metrics are in place, in check. We also have energy operations management module, where we can actually measure electricity, gas, water, or any type of energy usage in real time, and that data is recorded, and that data can be analyzed based on machine, based on shift, based on each and every product cycle, so that you can analyze it, and actually you can reduce consumption if there is anything that's not normal. For example, you can analyze it with respect to different machines for the same type of machines for the same type of product. You can see whether there is any deviation between machines. You can also see when you're producing the same product, how much energy I consumed for each and every product cycle. That way, actually, you can contain your energy consumption and make sure it's within the targets that you have. We have what we call ProData module, which is you can actually, in addition to production, quality, energy data, you can also get data from the machine settings, machine parameters, like for example, if you're using a plastic injection machine, you can get the injection pressure, you can get the length of the injection holding, or any type of process parameter actual values to the ProManage system, any sensor data that the machine is producing, or environmental sensors or alarms that the machine is producing. You can collect those, you can monitor those, and also you can do SPC analysis on those. And one layer up from ProData would be AI. So you can actually use these ProData values, the sensor and machine process parameter values, and you can actually correlate, or you can build models to predict quality or predict machine failure. So that would be AI on top of the ProData module. We have product labeling and forward-backward traceability, which means actually for each product or for each lot, we can label that lot or product, and actually we can attach production values or production process values or pro data values for each of those, that specific product. And once you actually ship the product, assuming there's a production, there's a quality failure in your customer, you can actually trace it back and see what the problem was, and you can actually recall the lot that you produced. If you send it to multiple customers, you can actually analyze these in detail. So these are very important requirements. The traceability is especially for automotive or healthcare industry. We also have a tool which we call Open BI, which means any data that we produce within the system, production amounts, stoppage values, operators, scrap reasons, stoppage reasons, all that other data, more than 300 KPIs, actually can be transferred to external systems. If you're using a BI tool or an AI tool or an AI platform, or if you're using a BI tool like Tableau or Power BI, Microsoft Power BI, actually the system can send this data automatically to your preferred BI tool. And the reason you would want to do this is you can, for example, you may want to combine production data that you get from ProManage with the financial data or cost data that you get from an accounting software. That way you can actually see the cost analysis and the income analysis for each and every product that you have. Or you can actually analyze the financial loss that you get from scraps, right? So these type of tools, our system is an open system, which means we can actually send data to other systems. Any data that we produce, we can send it to other systems with our open BI tool. Let's see if there are other questions. So there was a question about can we digitalize document sharing? We also have a documentation module, document module, which actually you can share any data, any document or data with your operators or technicians or within your company. For example, if you want to share safety documentation with your operators, within our operator interface, you can actually share any safety documentation. Or if you have 3D drawings of a product, or if you have instructions for how to produce a product, actually you can attach it to the product definition or the work order, and you can actually share that with the operator as well. So this helps manage the documentation within the company, and this helps to make sure the operators have access to all documents digitally within the system. Okay, so I'm going to talk a little bit about the system topology and how we collect data. So assume this is your factory, and you can have multiple locations of factory. So it means this factory box will be replicated multiple times. So within the factory, you have your machines and operators. In fact, all we have to do in order to install this system is mainly two things. The first thing is to install an edge software, which is a very light software in a PC, in a standard PC or a laptop, or if you have virtual machines in your servers, we can do that in the virtual machines as well. All we have to do is install an edge software. This would be a very light software that actually connects to the machines. If your machines have PLCs, if they are smart machines, or if they are Industry 4.0 already, all we have to do is actually connect those machines into the same local area network as our edge software. And we support Mitsubishi or Siemens PLCs, or if you have an OPC UA connectivity to your machines, or if you have CNC machines with MT Connect or Focus protocol, or if you have an plastic injection machines with Euromap, we support Euromap protocol, or MQTT protocol. So these are we have a lot of protocols that we support natively, which means if you have a smart machine, it's more likely that all we have to do is connect that machine into the same local area network, and the edge software will start collecting data. If your machines are old-fashioned, if they don't have Industry 4.0, or if they're not for Industry 4.0 already, if they are old machines, then what we need to do is use our IoT device, which we call Smart Counter, and we typically connect to the digital outputs of your machine to count production. And these IoT devices are Wi-Fi enabled, so either they are Wi-Fi connected or Ethernet connected. That means actually we can support your newer machines with Industry 4.0 functionality, or older machines, legacy machines without those capabilities, PLC capability. We can still cover those. And typically with as with an SME with 15-20 machines, the installation process usually takes less than a day, right? And once we have the edge software installed, once we have the machine connectivity, all the data is on Oracle Cloud. So our ProManage Cloud software is in Oracle Cloud, and we'll start actually collecting data digitally, automatically, and reliably. Nobody has to really do any manual data collection. You don't need to use Excel files or anything like that. And it's a reliable because it's done all in the background without any human interaction. We can also have operator industrial PC interfaces. So this is when you get to the digital package, the second package, where the operators actually can see their data in real time, their KPIs in real time for their machines, and actually they can enter scrap data or stop reason data. We can get those reasons from the machines if that's available from the machines itself. We can read them from the machine PLC. If not, the operators will have also the opportunity to enter some of that data into our system. And I'll talk about some of the tools that we have within the system. For example, this is our online machine monitoring tool, which is basically looking at your machines in a bird's eye view. So each of these boxes here represent a machine. The colors on the left side of the machine represents their status. So green means it's running, red means it's stopping, or it can be different colors, which means each of those colors correspond to a different stop reason. So you can actually see your machines in real time without necessarily going next to the machine, without talking to the operator, or without shouting at the operator within your shop floor. So you can see the machine status. So you can also see more than 300 KPIs within these boxes. So each of these boxes can be configured. For example, if I'm a production guy, I would be looking at the production metrics, like how many I produced within the day, what's my completion rate of the current work order. If I'm a lean manufacturing guy, I would be looking at how much the machine has stopped, how much it has run, what are the main reasons for stoppages. If I'm a quality guy, I would be looking at quality metrics. If I'm a maintenance guy, I would be looking at maintenance metrics, or if there is any machine that needs attention in terms of maintenance. The operators can actually can make technician calls or technician call requests within the system. So if I'm a maintenance engineer, I would be looking at the screen, but I would be only looking at the machines that have technician calls active on them. So this is all customizable per person or per user that's logged into the system. We have the machine history tool, which means you can actually, so you can see these steps, and these steps, each and every one of these steps is a production count. That means actually the system is aware of each and every production count, and the system can calculate cycle time for each and every production count. You can analyze the cycle times. You can actually see stoppages within this tool. You can see if there is any scraps within this tool, which operator is logged in, which job the machine is working on, etc. So this is a short-term analysis tool. We have dashboards. We have a lot of different dashboards. So for this dashboard, for example, we're looking at machine E8581. It has produced 684 products. You can see the shift speed. You can see the operator. So the machine the status of the machine is stopping. So stoppage is, the reason for it is planned stoppage. It's been down for a while. You can see shift top 5 stoppages. So the biggest reason for stop was machine failure. So there was other abrasive change, operator control, etc. You can see the OEE values, availability, performance, quality values. You can see the trends of those OEE values in the last hour. So the OEE was going down, the other metrics were stable or up. You can actually see the production quantity. So the machine has produced 70 in the work order. It's missing 10, which means the machine is behind schedule. Current quantity or current production was supposed to be 80, and then shift target is 100. You can also see shift top 5 scrap values. So this is one particular dashboard, but again, you can customize your own dashboard, and each personnel within the company can be looking at this from their own perspective, or they can customize it from their own perspective. Production guy can be looking at the production metrics. The production planning personnel might be just looking at mainly focused on when the work order will be finished, and when this work order is finished, what should I plan as the next work order to optimize the operation efficiency. Quality guy might be looking at quality metrics, like what are my top 5 scrap reasons, am I improving them, or are they getting worse. Maintenance guy again might be looking at maintenance metrics, why the machine failed, the reasons for failure, etc. So these are all customizable depending on the personnel that's looking at it. Just like I showed in the beginning, we have alerts. You can have alerts for weather, or you can have alerts for any app that you're using. In our case, the alerts will be an escalated warning system. These alerts can come to you via email within the system, via our app. And actually the alerts, this ProGuard, what we call ProGuard, will watch your KPIs for you. You don't have to be looking at the screen. You don't have to be looking at the reports all the time. So you can define target for any KPI within the system. For example, the operators can do technician calls. So the operator, the machine is let's say the machine has a problem. The operator tried to fix it. He couldn't, so he made a technician call within the system. Actually, the system watches for that technician call, and if the technician did not attend the call for 30 minutes, the system will send a warning to the person that's responsible for a technician call. So, and this is an escalated warning system, so you can have a low-level warning for 5 minutes, a mid-level warning for 30 minutes, and then you can have a really alert for, let's say, if the technician did not attend the call for 1 hour. Same thing for OEE or any other KPI within the system. So you might have improved your OEE values within your company. So now your target is 75%, and the production manager wants to know about it as soon as the OEE is below 75%. So you can define it easily within the system, and as soon as OEE drops below 75%, you'll get a warning within the system. And if you have a rule that no machine works with an operator, and if the machine starts producing product and there is no operator that's logged in, the production manager gets a warning. You can even have targets for production amounts. Typically, you don't want them to go below, but you can even define it your production amount that exceeds the target. And we have a lot of different KPIs, like I said, more than 300 KPIs. So you can define targets for each one of those targets, and the system will actually basically watching it for you, for your targets for you in the background, and alerting you as soon as there is a problem. So with the benefits with the smart manufacturing system, typically you'll see, first of all, you'll become a paperless factory. So a lot of companies actually they try to measure their metrics with pen and paper. They try to do it with Excel. They try to send documents to operators with papers, the instructions with papers. But with the system, with a smart manufacturing system, actually you are a paperless factory. At least you most of your paper operations will be eliminated. And I can show you examples of companies where actually documentation time and analysis time has been reduced to minutes within a shift. For a production manager, they were spending more than half of their time for documentation and analysis. But actually, documentation and analysis are all done by the system itself. and the shift manager or the production manager can only focus on just doing the production and also improving the production. With the system, again, the reduction in machine failure ratios will increase. So the machine failures will reduce because you are tracking each and every one of those failures. You're trying to put in place tools to reduce them. Your failure response times will improve because the system is actually tracking all those things, all those metrics for you. You know when there's a technician call, you know when the problem is fixed, and you know how to improve those metrics. Wait times, different wait times. I gave an example, like if the machine is waiting for a raw material or a semi product or a tool, they can actually go down to zero, pretty much zero. Ideally, wait time should go down to zero if in terms of if you have a smart manufacturing system, because the smart manufacturing actually does the communication between departments for you, and it tracks as soon as there is something that's not going right for you. And since these are in real time, actually you can be aware of the problem in real time and you can fix it in real time. And quality ratios improve significantly because again everything is recorded and you know the reasons for your quality problems and you can do activities to improve them, and eventually the lead time, agility, and effectiveness and profitability will increase with a smart manufacturing system. So this is a typical case study. This is an example of a ProManage customer that went live at the end of 2016, and they were producing about 160 products per hour. That's their metric. It's equivalent product per hour. That's the amount of products that they produce, which they can sell to the customer, to their customer. So they were using about 160, and they kept increasing until about 240 products, equivalent products per hour. So this is actually an increase of about 50% in production speed. And different companies use this increase differently. So they didn't buy any new machines, but they can produce 50% more. If they have orders, if they're working 3 shifts, and if they have orders from the customers, they can actually use this to increase their production without really making any new investment in machines. Or if they don't have new orders, if they're working 1 shift, they can actually reduce working days from 5 days to 3.5 days, which means they can actually save money, energy with the 1.5 days that they were actually producing products. So it's all up to the customer or up to the conditions on how they're going to use this credit, but the system gives them about 50% increase in production speed or the amount of products that they produced. With our cloud solution, actually multiple different benefits. So you can actually access the system anywhere in the world. You become anywhere in the world where you have access to internet. So any computer, any type of computer, any iOS or Android phone or tablet. We have apps for both Android and iOS. So anywhere you have access to internet, you can access your data, and you can actually be aware of the problems within your plant. So you become a proactive company. So you're not just reacting to problems, but you actually have a very good understanding of what your losses are based on data. And you actually are doing this without any use of paper. Everything is paperless, digital, and you have the full operational automation. So we also have our cloud system keeps getting updates. So we have more than 300 customers, different types of production processes, and they actually keep giving us new ideas on how to improve the system. And we take those ideas. We also use our product. Our product team works with the customers to actually improve the system to get new features each and every day. So we keep updating the system so that our system is the most advanced smart manufacturing system, and also our customers use the most advanced features that's available in the field right now. We do 7/24 support. So we have a ticketing system that's again digital, but also we do we have phone. You can call us, and we'll have 7/24 support in case you want to ask something or you want some new features. So we have an e-academy, which is actually, we have an online training system where you can learn about installation, you can learn about how to use the system, but you also learn about the principles of smart manufacturing. We had this question, how do you improve wait times in a machine? You can actually get tips on how to do those improvements, and you also learn how to create an improvement culture within your company. We also have digitalization trainings, and we also have a digital companies club where actually those companies meet, and they talk about their experiences. We typically get together once a year, and each one of them talks about how they use smart manufacturing, or how they use smart manufacturing in a specific application, and how they improved some of their processes. So some of them talks about, for example, how they improved their record keeping process, or how they become more paperless, or how they have reduced their documentation time or analysis time, because the system analyzes data. The system collects the data, analyzes data, and gives them ideas on how to improve the system, so that they can only focus on actually improving the production, or they can only focus on the production and have that peace of mind. We have a modular developing structure. So as I explained in the beginning, so we don't necessarily want manufacturers to take this jump in one step, and this is they have to be ready infrastructure wise. Their people have to be ready, the culture has to be ready. So we want them to do this step by step, start small, think big, and then we want them to improve on their smart manufacturing system all the time. So step by step, go all the way to smart manufacturing, then add modules, and go all the way to AI over time. But then do it at your own pace. Make sure you have a full grasp of the tools that you installed or that you're using, and then once you're ready, take the next step. And with the global competitiveness, so this is an important point, because actually the use of smart manufacturing systems in Europe and Asia is very, very common. In US, US is kind of behind, and we have customers in Europe that are using the system since 2002, and they have a huge advantage in terms of global competitiveness. They have improved their processes so much since 2002, but start as soon as possible. In order to be globally competitive, we need to start using these systems in US, and keep advancing in the digital tool world, so that you are globally competitive as well.